Hello and welcome back to Taking the Tech Exam with WM7X. In the past, we've talked about volts and amps and a little bit about how electricity behaves inside a wire, but what happens when that electrical energy leaves the wire and becomes a radio wave? Well, that's what we're going to talk about in this video, so let's get started. We've been using water as our analogy for electricity, so let's stick with that. So imagine a wave out in the ocean, and what you'll notice right away is that the wave cycles from a crest down to a trough and back up to a crest, and then the whole cycle repeats and repeats. So now let's say we've got a surfer riding the crest of the wave. As the wave moves along, so does our surfer. Okay, now imagine that we've got another surfer on the next crest and so on and so on. If we want to know how far apart they are, we'd measure the length between the crests, and we'd call that the wavelength. Very imaginative, I know. So one wavelength is the distance from one crest to another, or put another way, it's the length of one cycle of the wave. And if we actually measure it, we might find in this example that it's about 20 feet. But we want to be all sciencey, so instead of using feet, we're going to say it's 6 meters. And as a refresher, a meter is a little bit bigger than a yard, about 39 inches. Now, if you're sitting in a boat watching the surfers go by, you might see that there's one surfer every second. So if someone asked you how frequently a surfer goes by, you might say one surfer per second, which just means one cycle per second because they're on the crest of the wave. So that's the frequency. All right, so now we know that the length of one cycle is the wavelength and the number of cycles every second is the frequency. And you might notice that if you multiply the frequency by the wavelength, you end up with meters per second, which is a speed. It's the speed of the wave. So how fast exactly is a water wave? Well, it depends on how deep the water is and its temperature and a bunch of other factors. So let's see how all of this compares to radio waves. Most things are the same. Radio waves move through space just like water waves move through water. And radio waves have a frequency just like water waves, and they have a wavelength just like water waves. But there's one really major difference. Unlike water waves, radio waves always move at the same speed, the speed of light. And that's an insanely fast speed of 300 million meters every second. And just to give you an idea of how fast that is, the fastest jet ever built would take 35 years to go as far as light does in 1 hour. Now, you might be wondering how it's possible that frequency and wavelength always combine to give you the same speed. And it's because they're really just two sides of the same coin. When one gets bigger, the other gets smaller. If you turn down the frequency by half, the wavelength doubles. Double the frequency and the wavelength is cut in half. No matter what you do, they always give you the speed of light. And in fact, there's a question in the question pool about this, and it's exactly what we covered. As wavelength gets shorter, frequency increases. So you're good to go on that question if it comes up on your exam. The examiners also want to know how fast radio waves move, and you know that's the speed of light. So you've got that one too. And you might see a question asking for the actual speed, and you know that too. But don't get tripped up by 300 million miles per hour. If we're talking about the speed of light, we use meters, not miles. Okay, let's look at another question. What describes the number of times per second an alternating current makes a complete cycle? Well, wait a second. We've never mentioned the term alternating current before. We've been talking about radio waves. Well, it turns out the radio wave is an alternating current. It alternates from above sea level at the crest down to below sea level at the low point and back up to another crest. And that's what they mean by alternating. And by the way, the electricity in your house does that too. That's why it's called AC, alternating current. And with that, we can answer the question. All right, I hope you found this useful. When you get your license, you're going to be talking a lot about frequencies and wavelengths, so it's really important material. And you may even use the speed of light to help you build an antenna, believe it or not. It's pretty cool, actually, and we're going to get into that more next time. As always, if you have questions or comments, please leave them below. And if you want more tips on how to join the hobby or upgrade your license, click the subscribe button and ring the notification bell. We'll see you in the next video.